Why would I worry about it? All right.
Just go over there.
So where are we at?
7.4.
7-4.
2 questions. 7.
2 questions? All right. A twofer. All right.
63 and 84.
63.
84.
Oh, all right. Oops. Get the right section. Oh yeah, I think we did 63. Oh, well, to a point. I know I had questions about this. Yeah, we definitely talked about this.
Yeah.
Because I showed you the little shortcut. A really good first step is to bring this a negative out so that it turns around. You know, something I just now noticed that I missed last time is I don't think we actually did this problem too far. But if you factor this out, see how it would cancel? I don't know if anybody... There's an A up there, so an A would cancel. If I wrote that down, right? Yep, cool. So when you factor an A out, you can actually kill it. Anyway, is that enough to get you guys to get it going?
Yeah.
What's up? You all right?
Yeah, well, I was going through it last night, and I still didn't get it. Like, going on through it.
So what's the next step?
So factor 2 squares.
And 1 sorry.
So what I'm saying is you can do that right off the bat.
And the UCF will be LCD will be.
So the only thing that's missing something then is,
I think that's one is because I didn't.
yeah, he's missing an A plus 1, yeah. That makes it a lot easier, otherwise you got to give this guy an A. So you can always, if the same thing on the top bottom of a fraction, wherever that fraction is, you can always kill it. Alright. And what was the other thing? 84? Is that the, yeah, alright. Of course that's enough to keep up. Just to make sure you guys are with me. What's the area of that?
Oh, A equals 2x times
XY? And what's the perimeter?
2x.
Yeah, I got 2 x's and I got 2 y's. Good. So on this problem, they don't give you that rectangle. They give you this rectangle. X over x plus 4, x over x plus 5. But then you just do this. To get the area, you multiply them. So then you multiply them. To get the perimeter,
Yeah.
there's 2 of these plus 2 of these, and then you have to get an LCD, right? You guys with me?
Yeah.
So if you know the formulas for the area and perimeter of a rectangle, and really, I wish to God you didn't know any perimeter formulas. You don't have to know any perimeter formulas because perimeter is add up all the sides. So who cares what the shape is? What do you do for a triangle? You add up all the sides. Well, what if it's a pentagon? You add up all the sides. So get away from me. You don't need any formulas. But now you just got to plug in the sides. Just plug them in. So 84 is nowhere near as hard as it sounds. Maybe, when you first look at it. Is that all right? Okay, yeah.
Speaking of area, can you do number 51 on 7.6?
Oh, cool. I like it. Oh, that's what I forgot. Yeah. Shoot. All right. Oh, that's right. 51 says the height of a triangle. So a really good first step when a word problem, if it makes sense, is to draw a picture. Obviously, the problem was a shirt is 20% off. You're not going to draw a shirt. It's not going to help. But a geometrical problem, sure, I'm going to draw a picture. The height is 3 centimeters longer than the base. So what I was just saying to myself was I have a word problem worksheet that I keep forgetting to print out and bring in because there are some word problems mixed in here, right? But basically what you do is the first step is completely not mathematical of a word problem. The first step is purely English. What are the members of this word problem? What are the players in this word problem? What are the players? What are the parts? So it says the height of a triangle is 3 centimeters longer than its base. The area is this. Find the measurements of the base and height. So the base and the height. Cool. So I got the base, the height. So in English, you write down what the parts are. And here's the trick about math. We're going to translate from English into Mathish, right? So we're going to give these are the English names. I'm going to give them math names now. Now, the next step is to figure out what's just x. Because then the other guy is like twice that or 2 more than that or something, right? You with me so far? So which one, if the height is 3 centimeters longer than the base, which one has to be just x? Beautiful, because the height does something to the base. So I got to call the base x first. If I give this guy the name of x, then the height is 3 centimeters longer. Yeah, 3 plus x or x plus 3. Cool. Become a 3. Where people get in trouble is if it says it's 3 less than, and they write 3 minus x. No. What's 3 less than x? X minus 3. Right? If I said, what's 3 minus... listen to me. What's 3 less than 10? What number is 3 less than 10? You did 10 minus 3, right? So it's not math's fault, it's English's fault. When I say 3 less than something, the grammar is all freaky. It actually, math goes, oh shit, you mean this. You guys kind of with me? So, but this was nice. This was more than. Addition doesn't give a shit which way you do it. Right? So here, just to label things, I got x here. The height is x plus 3. So just to label my little picture. And what's the area formula for a triangle? Half. Good. Because any triangle is half of a rectangle, so the area would be 1/2 the base times the height. So, everybody still kind of with me here? Anybody not with me at all? So we can,
Say it again. What the area equals?
1/2 the base times the height. Yeah. Does that sound familiar? Yeah. So any triangle, if I just draw it again next to it, I at least get like a parallelogram or something. And the area of a parallelogram is base times height. And any triangle would be half of that. So that's the amazing reason why the area formula of a triangle is 1/2 base times height. I like it. So now you just got to fill it in. Area equals 1/2 base times height. They tell me the area is 54. Equals 1/2. What's the base? And what's the height? Kick ass. And just to help you out a little bit, what's the worst part of that equation? The fraction. So kill it, because it's an equation. So the very first thing I would do before I do anything else is kill the 1/2. How do I kill it? Kill the 1/2. Multiply by 2. So that dies. So I get 108, and then I can distribute that, and then you're going to want to make it equal to 0, right? So now solving it should be relatively simple. Setting it up should be the harder part.
Can you do problem 78?
Sure. Are we all good with how to go from there? All right. I don't know if I really believe you, but that's all right. That's what you want to tell me. Which one?
78, section 77.
7-7?
78.
Oh yeah, I love this problem. All right. You would, Jeff. All right. Because I feel like probably most of you have not gotten this far yet, which is not an indictment. It's just, holy shit, dude, there's a lot to go. I'll give you a little bit of a preview of this problem. So this problem says, according to the U.S. Census Bureau, there was 1 birth every 7 seconds. One death every 13 seconds. These are all averages, of course. It doesn't mean 13 die. No. On average, somebody. All right. And 1 new international migrant every 27 seconds.
7.6 if you're adding
7.7.
7.7.
Yeah. So believe it or not, this is a work problem. I make a new person in several different ways here, right? I make a new U.S. citizen person, right? Which one of these very obviously would be a negative contributor? Death. That's a loss. So I can make one person by birth every 7 seconds. And I can make one person by immigration every 27 seconds. But then I lose. I don't kill, maybe. Myself or, you know. I thought I know. I might black out and do there. Every 13 seconds. So overall, I get one person every, I don't know. That's the whole point. I don't know. X. X. And then you can solve that equation. So it is a work problem, just like mowing a lawn. So mowing a lawn here is equivalent to making a person, right? Not as much fun. Unfortunately, we have a few that we lose. And that equation is not complete, of course, right? Because there are people that move away. They don't just have to die. They're not dead to us. I'm going to Canada. You were dead to me. No, sorry. What's that?
People become vegetables.
Vegetables? What?
That's just morbid.
I didn't hear what you said. It's fine. All right. It's very binary. Either you're alive or you're dead. It's not the gray areas of law. All right. Anything else from homework? While we're on that topic. Stop talking about killing people. Anything else from homework? All right.
It's so fun though.
So I don't know if you guys understood what I said last time, but we're not going to spend a lot of time in 9.3 and 9.4. There are a couple things I want to talk about, and actually I want to show you some stuff on the graphing calculator too. Graphing calculator. So, guys, do this for me. Figure this out. Let's solve. Yeah, exactly. Trust me, I would be surprised if the answer is nice. Because I didn't even try to make it nice. So you might get fractions, and you should not be freaked out about that fact. So solving this system of equations, right? So they just come in, needs their quiz back. What's your name here?
Daniel.
Everybody else has theirs? Oh, go ahead. Oh wait, we'll do that in a second. This might be kind of, I don't know. Is anybody done with this? Is it really, really ugly, or did
It's
I?
ugly, it's gonna get ugly.
Yes. Yes, sir.
Question?
You got it? So what'd you guys do? Let me catch up to you.
Elimination.
Elimination method is an excellent idea. So which letter is better to work with elimination?
Y.
Yeah, Y is a little better because it's already opposite sides, right? Now you could use X, I don't care. So what are you going to multiply the first one by? Good, because now it's sort of like LCD, isn't it? You're going to give each one what they're missing respective to the other one, so that they end up the same, so they'll die. So you 20x minus 12y equals. The most common mistake I see is people forget to multiply that poor dude, and then it really gets weird. And then the second one, what are you going to multiply in by? Multiply by 3. So it'll be 6x plus 12y plus 9. So what do you get here? Let's see. 26x equals 49. Is that cool?
Yeah.
So x equals 49 over 26. Yummy. And this is where people might be like, I must have made a mistake. No, you're fine. So there will be some homework problems where the answer is fractional. They won't be maybe quite this ugly. And now, are you done? Obviously not, because there are two unknowns, right? How do you get y? Good. So we know this for sure. So then you pick either one you want. Which one?
2.
Sure. So in number 2, I plug 2 times this plus 4y equals 3. Sure, you can put a 1 under the 2. So then I can make this 49 over 13, right? This is where people just kind of give up, but this is a total sink your teeth in problem, right? It's not hard, it's just you got to go through it. So what's the next step to solve for y? Good. So if I take 3 minus 49 thirteenths, and of course to do that I need LCD, so this guy needs 13. So you get 39 minus 49 is remarkably enough negative 10. Are you guys with me? What's going on? You guys all right? What's happening? Don't. All right. We're all cool with the process here, right? We just have ugly numbers coming out of the process.
I just lost what you got over there.
Here?
Yeah.
So you're cool with the fact I can plug this into either one of these.
Yeah.
And in fact, if I do both, I have to come out with the same answer for y. That's the whole idea, right? They have to agree. So you guys chose this problem. I would agree with you because that's already positive now, blah, blah, blah. It doesn't really matter. So I plug that in.
And then solve for y.
And then I start to solve for y. So it's twice x. So right off the bat, I can kind of twice that. So that cancels down to 13. Subtract that over to get the y piece by itself. Right? So now I'm just solving. It just happens to be ugly looking. 39 minus 49 is negative 10 over 13. And then I do what? Even better than that, I multiply by 1/4. All right, who did something? Good coming. Guess, does that make sense? You don't have to, but if I have a fraction in an equation I'm trying to solve and I'm supposed to divide by 4, that's the same as multiply by 1/4. It just makes it look a little easier, right? So when you get there, so what's my answer then? 49 over 26? Negative 5 over 26. All right, cool. Somebody help me out. Who's got the calculator out? Tell me what 49 over 26 is approximately. Give me the first few decimal places. What's 49? My hand doesn't have it built in.
1.88.
I'm sorry.
1.88.
1.8, 8,
46.
4, 5, all right, blah, blah. So 4, 6, blah, blah, blah. And then negative 5 over 26? 0.18 or 9? I was close, right?
Yeah, 1.
negative 0.192, roughly. Is everybody with me? We just made those into decimals. You guys, I got this bad feeling here. Nobody's with me at all today. Shit. What happened? All right, let me go through this again. Everybody's cool with how to solve this problem, right? We're, unfortunately for us, the answer came out to be fractional. You should not give up. You should not erase it and hope that I don't notice that you didn't do the problem. You just throw it in and just tough it. You just tough it out. I mean, this is where you should be cool. Who cares that it's fractional? Just do it. Yeah.
So see, you said it was lucky because y was opposite. It was negative y, 3y, and positive 4y. Say it was positive 3y. Would you have to times it by a negative?
Yeah. Yeah, because I always want to add so I don't make subtraction mistakes, minus and negative and all that shit. So I always want to make these opposite signs.
So they have to be opposite so you can cancel them?
So they'll cancel when you add them together. I like it. All right. So my whole point, normally I want this as the answer for a textbook problem. You with me? But I want to show you how to do this problem on the graphing calculator. And then I'll actually tell you how to solve any equation in the universe on the graphing calculator. All right. That kind of sounds like a good skill. Yeah.
I got lost after the 4y, the top part right there. Yeah, right there.
So then, all right, cool. I subtract this to that side. Cool. Then I make LCD. Combine those. Yeah. There's like work being done at the same time. But the middle step here would be 4y equals negative 10 over 13, right? And then I divide it by 4, which is the same thing as multiplying by 1/4. Reduced negative 5 over 26. Cool. I like it. But again, that's computation level. You should just tough it out. Just do it. So now let me show you how to check your work in the calculator, which is really useful. You can never, for me, you can never do your work in the calculator unless I say so. If I don't say so, you better do the work yourself, but let me show you how to check your work. All right. Oh, and also I want to show you, no, I don't want to, I didn't go in. All right. I added one more thing to the website. That thing's getting loaded down. Oh, come on with all this crap. Well, there. Like that. Right here. Graphing calculator instructions. This is what I used to call the graphing calculator Bible. It's got all these different things. So I'm going to reference this every now and again. Uh-oh. Should have brought some scissors. That's like, what is happening over there? It's tearing into this graphing calculator. I don't know how many of you guys have, I was looking over the answers to the survey. It sounds like a decent number of you guys have used this before. How many of you guys have never used the graphing calculator before? All right, a few guys. All right. So a couple of things to notice right off the bat. Those of you who have never used a graphing calculator, how many of those people have never used a scientific calculator before? All right. So here's the nice thing with scientific calculators and graphing calculators. When you're entering a problem, it shows you the whole problem, right? It doesn't overwrite the last number. So if I have 3 minus 9 divided by 4, there. You with me? Now let's say I have to do something with this number. Let's say I have to take this guy's square root. And actually, let me make this more disgusting here. Let me do a couple things. Let's say I have 8 times 5 minus parentheses 2 minus 5 squared cubed. Yeah. Now watch, this is kind of cool. If I want to divide that, I can just hit the division key, and this little A and S means is answer. It means the last thing that was on the screen. So So I don't have to retype all that in. I just hit the divided by, and then divide by, I don't know, 9.856. There. Cool. You with me so far? All right, and then let's say, let's say I want to take a square root of that. Where's the square root button? Yeah, right above x squared. So they put all these functions that are together are inverses of each other. So if I hit second, this is like your shift key. Second squared, I get a square root symbol. Now, some of you guys, I want to point this out too. If you recently got your calculator, you might have a square root bar that kind of grows as you put more stuff in it. If you've used yours at all, you know what I'm talking about. Or you have, like me, it just opens up parentheses. So one of the biggest mistakes people make is they close that parenthesis too early. If I close the parenthesis at any time, I'm outside of the square root. So I'll show you a little problem with that. But right now, if I want to do the square root of that number, I could just hit second negative. See how it says A and S? A and S is the temporary memory button. So it holds in memory the last thing that was on the screen. It's very, very useful. Right? Then hit enter. And that's the square root of 1200, blah, blah, blah. How are we doing so far? So what I'm talking about earlier is, if I had to do the square root of 12 minus 7 times, you don't want too much, 1.3 or something. Right? And I do this, square root 12 minus, now it's already, see, it's no good. See, that's different from what I have up there, right? Because that's going to be square root of 12 minus 7 times 1.3. So I can't close that parenthesis until I'm done. Minus 7 times 1.3. Then I close it. Now that whole thing is under the square root. And again, some of you guys have one. Is anybody doing it? Your square root symbol just grows, which is much nicer, right? That's the updated operating system. Bam. All right. Cool. So there's some very, very basic stuff about how to use this calculator. Yes, ma'am?
Make a difference if you don't close the parentheses.
Oh, yeah, no. In fact, normally I don't. So if I did the square root of 8 minus 5 divided by 9, and I don't close it, it just assumes the whole thing is under there. It's only when you actually do close it that it says, oh, that's the end. Right? Otherwise, it just assumes it's the whole thing. Good, good. I like it. All right, so if I want to graph something, all that stuff is basically mostly up here. All of this is graph related. This top row. So if I hit y equals, this little y equals button, I can put in there functions. So if I put in there x squared minus 5, what should that look like? You guys know? Anybody know what an x squared looks like? Parabolic, I love it. So it's going to look like a U. So if I hit graph, and I give you, so if anybody's playing along with me, if your window is weird, all right, so this is a lot to kind of take in, but just do what you can. Normally, it's negative 10 to 10, negative 10 to 10. But can you imagine, very easily, you should be able to imagine that maybe I have an equation where this parabola is actually there. So then if I have the window set 10 to 10 like that, I won't be able to see the damn thing, right? So one way you do that is to change your window directly. You can control the minimum X and the maximum X and all that kind of stuff. You with me? So you can change that. Also, whenever I put a new function in, I go to Zoom 6. And again, all this stuff that I'm talking about is actually on that Calculator Bible on the website. Zoom 6 takes it back to negative 10 to 10, negative 10 to 10. It's kind of like my starting point is there. So hit Zoom 6. If anybody's trying this out, there at your seat, if you hit Zoom 6, your picture should look just like mine. All right, cool. So, going back to what it means to solve a system of equations, what does it mean graphically? Why did I write the answer the way I did? Why did I write it as a point? Beautiful. So that's a line. That's a line. The answer is going to be where they meet. I like it. No vertex, no parabolas. Yeah, sometimes it's called a vertex. But, so what do I have to do to this before I can plug it in to the calculator so I can graph it? Got to solve for y. It makes sense. It's a y equals button, so I got to have y by itself. So solving this for y, we can all do that. So I'm just going to do it real quick, if I can think about it. Become a 3. Become a 3. All right, because I would add that over, subtract it over, divide by 3. And then here, so negative 1/2 x. No, the 1 goes on top. There you go. Negative 1/2 x plus 3/4, because I would subtract, divide by 4. So if I put y1 equals that line, y2 equals that line, I paid enough money for this damn calculator, it should be able to tell me where they meet. Right? Okay. So, and y equals, if you're playing along with me at home, what did I say? 5/3 x minus 10/3. That's y1. And y2 is negative. Oh, and real quick, there's a minus button and there's a negative button. They are different. So if you use the wrong one, the calculator will go, syntax error, what the hell? It's just the way they had to hardwire it. So negative 1/2 x plus 3/4. Alright. And now if I hit graph, it's going to graph those two lines for me. One's got a positive slope, one's got a negative slope, so I know they're going to meet. What's the only way they would not meet? Which means what about their slopes?
Same slope.
Same slope, different y-intercepts. So the y-intercept just sort of like picks it up and moves it around. The slope says where it's going. Cool, I like it. So now I want to find that point. Does that look like, what did we get? We got 1.88. That looks like maybe, see this is 1, 2, that looks like maybe it's 1.88. Comma, negative 0.192. Maybe that's, it's really close to the 0 there. Maybe that's negative 1.192. Are you guys, at least eyeballing it, it looks right. But that's nowhere near good. I want to know the exact answer. Table's not good enough. Table's not specific enough. Trace is better, but trace is not good enough. Damn, Jeff. Look, that gets pretty close, right? Well, that ain't the right answer. I should be able to do it better by hand than the calculator can do, right? You with me? Calculator should be able to do it better than I can do by hand. So here's how you do it. You go to second trace to get up here where it says calc. Here's where I can calculate stuff related to my function. So if I had a parabola, it makes sense I could figure out the maximum or the minimum. Right? The intersect is what I want to use right now. 6 and 7 are calculus, so don't worry about those. So if I use number 5, it's going to ask you 3 questions. It's going to ask you, what is your quest? No, it's going to ask you the first curve. And what's really cool is I can put in here like several curves. I forget how many I can put in. It goes off the screen. Good Lord. 10. So when I'm doing this intersection, let me do it the long way first, and I'll show you the shortcut. So the first curve, look what happens where my cursor is. If I hit up and down, do you see what it does? It bounces between the two equations, right? So if I want to move on it, I have to move left or right. So I always see people get real frustrated. If you only had one equation up there, hitting the up button wouldn't do anything. And like, my calculator's broken, it's not going anywhere. No, left and right moves you, right? So the question is, what's the first curve? Okay, here I'm on this curve, enter. And see how it bounced up to the next curve for me? That was nice of it, right? So it's on the next curve, it's on the other. And I'm curious if anybody's like, what curve? That's a straight line. But in mathematics, that is a straight curve. Okay. So it bounces to the next one. I hit enter. And then it says, what's your guess? So I put the cursor right as close as I can to the answer, somewhere in there. Enter. And there's the 1.8846 blah 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 and the negative 0.192 blah blah blah. All right, how we doing? You guys are really bored, which is actually good. I think most of you have used graphing calculators a little bit at least, right? But a few of you not really. Let me think. What else can I show you while I'm in here? Oh, one of my favorite little things, real quick. It's the last thing I'll show you today. The next day, on Monday, I'll probably bring, on the day of the test also, I'll bring a little bag of graphing calculators. So if you don't have one yet, or if yours dies during the test, which always sucks, you can just come up and borrow another one, right? I only have so many, so you want to get one so you make sure you have one. Because once I run out, it's too damn bad. But one of my favorite little dudes is ZoomBox. And this sort of feels like, Google Maps, except you can't swipe. But everything's happening in there, and I want to be able to see it better. So see how that little cursor's moving around? If I hit enter, that's one corner of a box. So if I hit down and over now, the box opens. And if I hit enter again, it's going to zoom in on that little area that I caught. So a lot of times you graph several things and something interesting is happening and I can't really see it. I just zoom box in so I can see it better. So now I can see a little better where they meet. How are we doing so far? All right, and I just lied. Let me show you one last thing. And this is the thing I think, to me, if I were you, this is the thing that would be really amazing and awesome. What I've just shown you is a way to solve any equation ever, anywhere that exists in anybody's head, blah, blah, blah. As long as you can actually solve for y. Let me be careful. As long as there's only one variable in it is what I'm trying to say. So if I had an equation like x squared minus 4x plus 2 equals the square root of x cubed plus 5x. Can you imagine trying to solve that by hand? Do you understand what you would have to do? You'd have to square both sides, which means FOIL that. Or, FOIL that, whatever the hell the thing would be. You guys kind of with me? So I don't want to do that. And once you do that, you have to factor what you got. I would end up with x cubes and x to the 4th powers and holy shit. So here's what you do. You go to y equals. You plug in one side. X squared minus 4x. What is it? Plus 2. Let me see if I made something that actually has an answer. That would be really good, Jeff. And then square root. X to, here's your to the button right there. That's what I call the to the button. X to the third.
Plus 5x.
Thank you. Alright, so one side I let be y1, and the other side I let be y2, because the answer will be where this curve meets this curve. So that's why it makes sense, this process to solve it. So if I hit graph now, let's see. So first off, my window's all freaky, right? That looks helpful.
Zoom standard.
Good, so hit zoom 6. This is a good place to start. This might not be the best, but let's see what happens. Ooh, all right. So tell me two things. This is good. I was hoping something like this would happen. How many answers do you think there are going to be? It looks like there's going to be 2. One of them I can see, but not really that well. And the other one's going to be where?
Up at the top.
Yeah, so let's do 2 things. I'm going to zoom in on the part that I can see, just so I can see it a little bit better. And then we're going to figure out how to get up here and find this other answer up here. So if I zoom in on this area, so zoom box, zoom in on this little area so I can see better what's happening. Let's see if they actually meet here. Hey, look at that, sweet. You guys still kind of with me here? All right. And then I can do the whole second calc, intersect. And here's the shortcut. I forgot to show you the shortcut. The shortcut is just put the cursor on the answer and then hit enter. Oh, I'm sorry. What happened to it?
Go to sleep.
Wow, it's been overused. It was on for so long today.
What's the right dead? the red lights
Oh, the lamp is over here.
burnt out.
Oh,
Probably burnt out.
oh well.
That's it. That's the first. Hey, class is over.
All right, you're using your imagination. No, what's really nice is this is obviously not the whole class. So,
Ow.
in order to find the one after the one that we were just about to get, you would go to Window and make Y max bigger. Does that make sense? Because the next answer was higher off the screen. So I'm only able to see up to 10. Maybe I want to see up to 40, just to see if they meet up there. All right. Thankfully, that was the last thing I was going to show you on there anyway. All right, good. Hopefully the bulb didn't die. I got to remember to sell. Okay. Technology. It's so awesome. When it works. All right. Questions? Yeah.
Absolutes on the calculator. I forgot how to put absolute in what that
You hit the math button. Math button sounds like a really good button. And do you see how it's the very first thing, I think, if I remember right? Do you see the math button? There's a button. Oh, you go to number. Let's see.
Oh, there it
Go
is.
to math. Yeah.
So if I needed to graph it, I would do y and absolute of what the equation is.
Exactly.
Okay.
Cool. Yes.
So what if we have cubes? How would you?
You use that to the button. I had a cube here, right? And so I used the caret. It's over there underneath your down arrow.
Yes.
Yes. So that would be to the third power. All right. How we doing?
It's actually called.
Huh?
It's a button actually called.
Caret. It's the caret.
It's actually called carrot.
It's actually called
Okay.
caret. Yes.
Wasn't true.
All right. Anything else from that? That was weird time. Okay. So overall, that section 9.4 should be really simple. 9.3 was graphing, and I'm hoping that you all should be decent with graphing. If I wanted you to graph, we talked a little bit about this already, but if I wanted you to graph, bring in this absolute value stuff we were just talking about. I want you to graph this, right? These are absolute values. Of course, what's an absolute value do? Makes everything positive or zero, right? If it's zero. So we're going to talk a little bit more about absolute values and how they act when they're inside of equations. But right now, all I want to do is graph this thing, right? So how would I graph this if I'm not sure what it's going to look like? Yeah, beautiful. Make a little XY table.
1, 2, 3, 4.
Yeah. And normally I say do like a mixture of negatives, positives. We actually have to go at least that far. I don't know if anybody sees why. The most important point to find on a parabola or an absolute value is that turning point, right? What we call a vertex on a parabola. You with me? That's the most important point to find. I just happen to know where it is. But you have to make your table long enough until your outputs kind of turn. So we'll see that happen. So if I plug a -1 in, what do I get out? So I get 4 minus -1. Yeah, 5 minus 1, 4. Plug a 0 in. 4 minus 0 is 4, minus 1 is 3. And of course, it's going to, now we know the pattern. Yeah, because 4 minus 1 is 3, minus 1 is 2. 4 minus 2 is 2, minus 1 is 1. 4 minus 3 is 1, minus 1 is 0. Is everybody with me? All I'm doing is plugging stuff in. All right, some of you guys kind of look a little. 4 minus 4 is 0, minus 1 is -1. But what do I get when I put a 5 in there? 4 minus 5. 4 minus 5 is, and what's the absolute value of -1? 1 minus 1 is 0. See, so that turn, I can see the turn now, right? That's the point you got to find. If you don't find that point, you're going to think it's a straight line, and you're completely wrong. How are we doing so far? So parabola looks like a U, because anything to a power different from 1 is going to be curvy, truly curvy, not mathematically curvy. Absolute value is a V, because it's a first power. It's linear, except it turns because it's like, oh shit, I can't go negative O. You with me? Parabola is more, okay, let's turn. Yay. All right. So if I want to graph this thing now, cool. So I got negative 1, 4, 0, 3, 1, 2, 2, 1, 0, 1, 1, and then 5, 0. So that's where it turns. So here's my V. Bam. Make your dots bigger. Yay. All right. So if you have a function that you're not sure what it looks like, or you're not sure where it's going to do something, you make a table. If I have a straight line equation, you should not have to make a table. I don't want to see tables. You should be able to get the slope, the y-intercept, and do it from there, right? So take a second real quick here and graph this line for me. Let me make it more interesting.
No. What? Last week?
Last loops. Did something on purpose there. See if you guys get this. Is everybody cool with that? You solve for y, get it into mx plus b form. What's the slope? Slope is 4 over 3, which means I would rise 4, run 3, right? Beautiful. Mathematically, what's equivalent to positive 4 over positive 3? Negative 4 over negative 3. So mathematically, the math would say, well, that's the same thing as that. That number, these numbers are the same. But visually, it becomes something very different now. I have to go down 4 and back 3. It's kind of nice. And of course, it only makes sense. If I should be able to go up 4 and over 3, I have to be able to go down 4 and back 3 and still be on the line. It's got to work both ways. Otherwise, I never get back home. Come over to my house. Oh shit, I can never get back home. I got to keep going. And then you roam the earth. So you get back home on the other side. So, and what's my y-intercept? 0, 4. So I start there, 0, 4. And let's say this is the top of my paper. I'm like, oh shit. So now you just make it negative 4 over negative 3, right? So I can go down 4, back 3. Cool. So now I end up with a positive slope like I'm supposed to, right? And then make it somewhat straight, sort of. All right, maybe. Now here you could have found like intercepts and done it that way. But I want you to do it this way if you can and get more practice with that. All right. That should be relatively simple to do. All right. And before I get into chapter 10, one other thing with this, I keep using this notation, but I want to make sure everybody's cool with this. So real quick, if I gave you this, can you tell me what f of 2 is? It's amazing. You plug 2 in for the x. That's all you do. So it's very single-minded. It's just substitution.
3x.
So it'll be 2 squared minus 1 over 2 times 2 plus 4. 3 over 8. Cool. All right, that's neat. What's f of h? H squared minus 1 over 2h plus 4. So people kind of freak out when I'm putting a letter, but it's nice because then I can't do anything. So I'm done the minute I put it in. Yes, sir?
Which chapter is it?
This is still section 9.3. 9.3's got graphing and functions, and 9.4's got systems of equations. I know I'm kind of bouncing around, but this is review, so I'm doing it as I remember it. This is 9.3. So what about f of 3 minus 2x? It's amazing. Yeah. I mean, it cannot do anything other than plug stuff in. And then, of course, you could FOIL this out and all that kind of stuff. You guys could clean it up after that. Is that cool? Yes, ma'am.
So if we were to give that answer, would we just plug in, would that be acceptable?
No.
Would you like us to work it out?
Yeah, work it out. Keep going, keep going. Yeah, cool. I like it. And whenever you have simplifications you can do, you should do it. Cool. I like it. All right, that's not too bad, right? And again, this is a review. You got to speak up now if you forgot this stuff or not sure about something, but most of you guys look like, all right, man. Yeah.
Could you do that with 3
Which, sorry?
because,
Here?
yes,
You're cool with just putting a 2 in, right?
like
And then 2 squared is
4.
minus 1? Yeah, so once I put that in, I just work it out. Yeah, cool, I like it. All right, so let's get into some new stuff. Chapter 10, section 10.1. I think most of you guys have never seen some of this stuff. We'll take a break here in a little bit. So we've already talked about interval notation. We talked about graphing solutions to inequalities, where you shade, and how that relates to interval notation. So I'm going to jump into the new stuff here. Let me introduce it this way. So there's the idea of sets, right? Be careful how I say that. And some of us, you got to be careful. For example, if you solve a problem, x blah, 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 and at the end of the problem you get x equals 1 or 2, and if you write your answer like this, what's wrong with that? It looks like it's either a point or an interval notation thing, right? So that's why, what do we use for sets of numbers? Do you guys know? Brackets. All right, if you have trouble making it perfect, just